Hey everybody, Lars here. Time for the last video we're going to get for Unit 2, and this is a fun one. Um, Long story short, I run the CAVE, Collaborative Lab for the undergraduate computer science students. And back when we first started the CAVE, 5, 6 years ago now, it's a long time, we would have students come into our lab and ask us how to learn Python. And back 5 years ago, there are no Python classes to take. Now, you have my Python class, and I think there's some others. And but back in the day, there weren't any Python classes to go and take. So what we would tell our students to do, and I queued some stuff up here, is go to learn Python the hard way. That's actually why it's one of the resources that you're doing for your midterm project. I want to see what you think of it and how you like going through it. Anyway, students would come in and we would tell them, hey, go to learn Python the hard way and do the however many chapters it is, 50 chapters or whatever. Don't cut and paste and go through all the exercises, and slowly but surely you'll learn Python. You'll learn what it's about. When you guys do your project and you go through learn Python your hard way, you'll see it goes through comments and variables and printing to the screen and some other things. Very similar to the stuff we're doing right now, the beginning stuff. And then we would tell them, after learn Python the hard way, we would send them to this site, Project Euler. I always tell the story. It's like I'm a broken record now, but I always say Euler because look at it. It looks like it should be pronounced Euler, but it's really pronounced Euler. And I was corrected in college in a math class by a math professor in front of a whole class full of students, and it was very embarrassing, so I will never forget it. That said, I still make the mistake all the time. I go back and look at old videos, and I go back and look at stuff, and I say Euler, 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 Euler. So I may even do it in this video. One never knows. So it's really pronounced Euler, and Euler, as you may or may not know, is a famous mathematician, and the site is basically named after him. And what the site's all about is, if you come over here to archives, you'll see that it lists a bunch of problems, and most of them are number theory problems, but they range all over the place if you look at them. If you look at the first one, it's pretty simple. Actually, let's not look at the first one. Let's look at something like number 3. The prime factors of 1395 are 7, blah, blah, blah. What's the largest prime factor of this huge number? Boom, boom, boom. It provides a lot of number theory problems. And we would tell our students to learn Python the hard way and learn as much about Python as they could. And then when they wanted practice problems, to come here, to come to Euler and do as many problems as they could. And when you log in, well, actually, I set something up first. Let's go to sign in. I am not signing in as myself. I'm going to sign in as P4DS-F2016. And I will put in the password. And I'll put in this confirmation code so it knows I'm not a bot. And hopefully, yay, we have signed in successfully as P4DS-F2016. And if you log in, you'll see that you have the listing of all the problems, but only now you can go look at statistics. And you can, get to certain levels. If you solve between 25 and 49 problems, you're level 1, level 2. So you can look for that. You can also come to the problems and look at the problem statistics. We used to tell our students to do as many problems as it took to get into the top 5%. So right now that's 56. So if they did 56 problems, they would be what we call the 5%er. And later, maybe 2-3 years later, I actually ran a seminar in the computer science department called Just Euler. And it was about problem solving. It was about problem solving from a cognitive psychology standpoint and some other standpoints. And what I did is, at the end of the class, I had the students solve Project Euler problems. It was also a stealth way of teaching them a little bit about Python, because I usually use Python for this. If you go online, you will see that there are a lot of solutions for a lot of these problems all out there. Stack Overflow, a bunch of other problems. And to be honest, what I'm doing here isn't the best thing in the world to do, because you're supposed to leave all the problems out there pristine without their answers so that new people to the site, like many of you are going to be, have their own chance to solve the problems. You don't want to, spread the solutions out there so people can just look them up or see them, or you might wreck it for them. That said, Stack Overflow has at least the first 100 of them up there. So avoid that. Sometimes people go look. I mean, if you're a grown person and you don't have, all day long to sit and solve and tinker over these things, and you genuinely work at one for like 2 or 3 hours and it's making you crazy, then maybe you go to Stack Overflow and get the answer and go, oh, okay, or you get a tip or something to help you along the way. But for the most part, it's probably better to avoid that and try to solve them yourself. So what we're going to do today, because you now have data, arithmetic, strings, lists, and loops, we have enough that we can actually start attacking real problems that are out there in the real world. So what we're going to do is we're going to go and look at archives. We are going to go and look at Euler number 6. Okay. So why don't we set about doing that? I'm starting from scratch again. Not prepared. Let's see. I'm going to say file. I'm going to say new file. I'm going to bring this over here. I'm going to very simply, in the comments up top, just say Euler 6. And then I'm going to do something that I usually do in this. I am going to actually go and cut and paste the description of the problem, and we're going to put it right in our code. So we're going to have it. Let's do that, and then let's say paste. And that doesn't look very good, so let's do that. And let's do that, and then we have it. Good. I don't know what happened to that F, but we'll put it back in there. All right. So let's look at this problem, and this kind of messes up the superscript. So let's go back to the web and look at this problem. The sum of the squares of the first 10 natural numbers is 1 squared, 2 squared, blah, 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 equals 385. Okay. The square of the sum of the first 10 natural numbers is 1 plus 2, all the way to 10. Square that number, and it is 3025. Hence, the difference between the sum of the squares and of the first 10 natural numbers and the square of the sum is 3025 minus 385 equals 2640. Okay, so we've been given what in education we call a worked example that shows us pretty much an algorithm of how to find a sum square difference as it's defined by Euler. But, and this is the rub, right below that it says find the difference between the sum of the squares of the first 100 natural numbers and the square of the sum of the same. So basically, they've shown us how they did it for 10. Now we need to do it for 100. As programmers, and especially programmers who just learned about loops, this is a natural for us, because what we're going to do is we're going to code something up that solves this problem for 10 for the worked example. And then if we see we're getting the proper solutions, then we know we're good to go, and we can go alter our loops and solve it for 100. So let's go ahead and do that. All right. What's the first thing I want to do? Well, first thing I'm going to do is save this guy, so that when I hit my save, it doesn't make me crazy. All right, let's Python Data Science, Fall 2016, Unit 2, and I will call this guy Euler 6. All right, so we have it saved. And of course, like I always do, when I'm done with this video, I'm going to take this piece of code and I'm going to pop it up in your resources so you'll have it to play around with. All right, what's the first thing we need to do? The sum of the squares of the first 10 natural numbers is 1 squared, 2 squared, blah, blah, blah. They messed up the superscripts. 385. So let's put in a comment and say find the sum of the squares. So how are we going to do that? I'm going to create a little variable called sum of squares. I'm going to make it equal to 0 because I'm going to use it when I go into my loop. Then I'm going to create a loop. I'm going to say for I in range. What do I want to go through? To solve this one up here, I want to go from 1 to 10. So I don't want to start at 0, so I'm going to put a 1 in there. And I'm going to put in an 11, because 11 is what? The first thing we don't want. Okay? So that's going to give me a loop, and it's going to go from 1 to 10. And what do I want to do when I go into that loop? Let's see, I want the sum of the squares. So I'm going to say sum of square equal to sum of square, because I'm going to make it like an accumulator. But what do I want to accumulate? Don't want to just accumulate I in this scenario. I want to accumulate the square of I. Then I'm going to jump out of the loop, and we will print things incrementally so we make sure that we're being good soldiers and getting good answers. Okay, so now I run that. I run it. And I get 385, which is outstanding because, as we can see by the little demo up there, 385 is what they had. So we are in Fat City. We have the first part of our answer now. Let's do this. The sum of the squares is, let's do that. Make it look a little bit better. Okay. We are a third of the way there, because really this problem breaks down into 3 different things. Now we have to find the square of the sum. Okay. Now, dirty little secret. I'm just going to cut and paste this code right here. Okay. Actually, I'll grab that too. And then we will copy it. We'll come down here, paste it. Actually, let me do it right there, and get rid of that right there to make it a little bit more readable. And now we want to change things around to do the square of the sum instead of the sum of the squares. So what do I want to do? I'm going to change this variable name. So it's square of sum, and that loop is fine. And then for square of sum, I want that to be equal to square of sum plus what? This time I do want just I, because I want to add them all up first. And then when I add them all up, I want to square it afterwards. And that's what I'm going to do. I'm going to jump out of the loop, and I'm going to say square of sum is equal to square of sum squared. And then I'm going to say the square of the sum is square of sum. All right. I'm going to save. I'm going to hit F5. And oh, look, I got my new little thing. The sum of the squares is 385. Correct. That's what we had up there. The square of the sum is 3025. Is that correct? Yes, it is, according to Euler. Okay, so we're in good shape. So now we have to do the very last part, which is first 10 natural numbers, squares, find the difference. So we need to find the difference, which is easy, and we'll actually just do that in a print statement. We'll print the difference is, and then we will just do square of sum minus sum of square. Okay? And so now when we run our program, we get 2640. And indeed, the answer is 2640. So now, in this little code block right here, we have pretty much solved the problem the way it was solved when it was introduced to us, the way Euler had their worked example. So we're in pretty good shape. We wanted to find the sum of the squares, so we hopped into a loop and we added them all up, and we have them in that variable right there. Then we wanted to find the square of the sum, so we hopped into a loop and we added up all the terms. And then when we popped out, we squared it because we want the square of the sum. Okay? And then just down here, right in the print line, we got our answer. Now, we're not done yet. Go back to Euler. Find the difference between the sum of the squares of the first 100 natural numbers and the square of the sum. So we need to solve this for 100 numbers, not 1 to 10, but from 1 to 100. So how would we do that? It's easy. All we got to do is change 2 loops. Watch. Boom. I'm going to make this 101. I'm going to make this 101. All right? So now my loops are going from 1 to 100. And they're going to square all those numbers and add them up. And then this one is going to add up all the numbers from 1 to 100 and then square that result. And then we're going to find the difference there. So let's save and let's run. And now we get a completely new set of numbers, obviously, because we've done something different. Okay? So according to the way the problem was defined by Euler, we have an answer, 251,64150. All right? But there's one last thing I think I want to do. When you have code like this, and you have two variables that should be the same, but sometimes you want to change them to get different results, it's a good idea to use a variable to do it, and then you can set that variable when you want to change things. So I'm going to create a variable called limit. And I'm going to make it equal to 10, okay? And then all I'm going to do is in my loop, remember we can use variables in our loops. I'm going to say limit. And then I'm going to run it. But if I run this, I'm going to have a problem, right? Think about it. That was the pause where you could think about it. I don't want 10. I want 11 there because I want the first thing I don't want, okay? So there's a couple of ways to solve that. I can make the limit 11, but in Python, readability is important, and I'd really like limit to be, you know, something meaningful, like the number that I'm going up to. So what I'm going to do to correct the problem is I'm just going to say limit plus 1. And actually do a little bit of addition inside of my range. And that'll work just fine. Okay? So now I've set limit to 10. And if I rerun the program, I get my old answers again. And it seems to be working. Everything is fine. So now I've used a variable in my range plus a little bit of addition in order to just set this one variable. Then all I have to do is change that one variable to 100. And I'm running things for 100 again, okay? Now, actually, truth be told, you could actually create an input statement here so that the user could input what number to go up to every single time. We're not going to bother with that right now, but look at this code right here. That pretty much is the answer to the problem. At least I think it is. We're going to find out if it is, because in Euler, what we can do, and I'm going to highlight our answer, so we can cut and paste, and we're going to go back to Euler, and I am still logged in as P4DS F2016. You know what I think I'm going to do? I will change the password on that because it's one of the passwords I use all the time, so I'm not going to give it to you. And I'll change the password on that, and then I'll tell you what it is. So as a class, if you want to go in and start doing Euler problems together, you can solve them. Okay, and you could actually in the forum say, hey, I solved Euler this, or I solved Euler that. Don't advertise solutions, because what most people do, and what I'm actually going to recommend you do, is go get your own. Go to Project Euler and register and get your own user ID, and then you yourself can start. Because after this class is over, you're still going to want to do these, and you're still going to want to use them, and it's good. And you're going to see we can chart our progress. But right now, what we're going to do is see if our answer is correct, and this is actually a cool little process. So there's a box down here for the answer. I'm going to paste the answer in there. Then I have to put in a little number, a little captcha, so it knows I'm not a bot. And there's my answer, and there's my confirmation code. Now I'm going to click check, and if my answer is correct, Euler's going to come back and tell me that I solved number 6, and it's going to give me a big green check mark. And that big green check mark definitely gives you a happy feeling every time you see it. Let's see. Ba-dun, dun, 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 dun. And we got the big green check mark. So now we have solved problem 6 at just Euler. And you can see Euler hopes that we enjoyed solving this problem. And oh, here's your warning. Please do not deprive others of going through the same process by publishing your solution outside Project Euler. What could that be? Like a YouTube video for a Python class? I'm lawless. They won't catch. I'm too old to be caught alive right now. There's no way I'm going to sit in a box. So I'm on the run from Johnny Law. Euler is not happy with me. Well, I've said it before. It's only problem 6. It's not exactly the toughest problem in the world, so I think the planet's going to survive. That said, don't go around advertising the solutions everywhere, because it's a good point. People do want to solve these things for themselves and get things done, so don't do it. But look at that check mark. I love that little check mark. Now, if we go to statistics, you can come down where problems, where's my listing? Is it, oh, archives. If I go to archives, I can see, where is it? Oh, progress. Go to progress. And you can see right here, number 6 is green because we've solved it, okay? So if you click on it, It'll take you back there, and now you have the answer, and it'll tell you when you solved it. So Euler's neat. Euler lets you keep track of your problem-solving progress. And if you go to statistics, this is going to be cruel. You're going to see that quite a few people have solved exactly one problem. All right? Basically everybody. That's what they do. They solve one problem. But that's not the point. The point is that you now have, let's go find out, 561 nasty old number theory problems to solve with your programming skills. And you'll find that Python is actually one of the more popular languages for solving Euler problems because it's, easy to do mockups. It's real quick to just do little pieces of code. There's no crazy setup. A lot of people use Java. Some people use C++. Some people use MATLAB. But there's a lot of solutions out there for Python when it comes to the Euler stuff. And Python's pretty good as far as getting down and dirty and dealing with numbers. There's a lot of Python libraries out there that help you deal with numbers, NumPy, and things along those lines. So that is Project Euler. All right, go there. Get an account. It's free, 100% free. You don't have to spend any money. So you get an account, and then you can go to the archives, and you can bring up problems and start solving them. Okay, and then when you do solve them, you can go to your progress bar, and you can see where you stand. And then if you want statistics, didn't I click that? Something is wrong with my browser. All right, well, I'll figure that out some other time. If you went to statistics, you can figure out if you solve the first 50, you're part of this class. If you solve 100, you're part of this class, boom, boom, boom. And things work that way, all right? So here, and you don't have to type it up. I will put it up in our resources. Here's the solution to Euler number 6, okay? The point of this video and the point of all this is to show you that now you can actually start doing things. You can actually start solving problems with some of the Python you know. And slowly but surely, as you acquire more things in Python, functions, files, we're going to talk about libraries in Unit 3. We're going to do some other things. You're going to learn about searching and sorting in Unit 4. You're going to learn a little bit about object orientation in Unit 5. As you learn all these things, it's going to become useful to you. And you're going to actually be able to use it to solve different problems and do different things, all right? So there's Project Euler. Make sure to go there and at least, check it out a little bit, look at some of the problems. If you have time, do the solutions. I have a directory on my laptop right here where I keep all the Euler solutions. And I did all mine in Python. Big shock there. All right? So there's Project Euler. As far as announcements are concerned, we're chugging along pretty good. I'm shooting this Monday night. So over the weekend, you got the review video 1, review video 2. Today I uploaded, or actually super late last night, I uploaded the midterm assignment data sheet. So you can read about that. You know about that. It's not due to November 4th, but watch out because it'll catch up on you. All right. As I told you in my announcement, I did the grades. Now I just have to send them out to you. Hopefully I will have time to do that tomorrow night. Everybody did well, so that's cool. Keep doing what you're doing. In 3 days, on Thursday, you'll be a week away from the end of Unit 2. And this is almost the last of the resources I want to get you. Tomorrow, Tuesday, I will sit down and put together the assignments for you. So tomorrow night, I should be releasing the assignments for this unit. And then you will have, with 9 days to go, all your resources for this unit. You have your slides, you have your Zell reading, okay? Then you have your review videos. Then, a little bit more than a week before class, I try to get you the assignments. So now you know what you have to do, and now you've got a puzzle to solve, and you can use everything you've read about and tinkered with to attack those problems and solve those problems, okay? Don't forget to get in there and do the forum post. I know people are, waiting for this week to do something along those lines. But I think we have 38 students now. A couple of people dropped, I think. And we've only got like 4 things in the forum. So make sure to get in there and do those forum posts because I want them so that your classmates can read them and see what everybody else is thinking and see what everybody else is doing. So when you do that forum post an hour before the end of the unit, it doesn't do us any good, I've always tinkered with the idea of making the forum post due earlier than the end of the unit. I'm not going to do it now because I'm not going to, do something you didn't know was coming down the pike. But maybe later on in the course we'll do that. Because actually, in the first time I ran this course, we got some interesting conversations about the different videos and the different things. And I've always loved that Slavin talk. I always thought it was fascinating, and it's really cool. So get in there and do those forum posts, okay? All right. You be good. Enjoy the debate. What a circus. Oh, actually, when you're seeing this, you'll have already seen the debate. So I don't know. I have no idea what's going on in this country. Also, if you're a normal person, just forget the stupid debate and watch the football game, because that's probably what I'm going to do. Saints are playing the Falcons later on. So I'm going to have that on my big screen TV, and on the little TV, maybe I'll put Trump and Hillary on, just in case they run at each other and fight, because I don't know who'd win. Hillary's a tough old broad. All right? All right. Then that's it for this. I am going to get out of here, but I'll be in touch via announcement over the next couple of days, get you those assignments. And keep doing what you're doing. Do a little bit every night, okay? You don't want to sit and do nothing for 2 weeks and then try to do everything in one night. Because like I always say, it's a crappy way to learn, all right? But you guys are doing good, so I ain't worried about it. All right, you be good. I'm out of here. Have a good night. Bye-bye.